Hi everybody, Jonathan here. In this video, I'll be giving you my take on section 7.5, which is about strategy for integration. So the basic problem is that on a test or in the real world, nobody's going to be telling you which type of integration technique to use, and furthermore, a lot of integrals are hard enough where it's not going to be clear what technique to use or even what technique is going to help. So this section is to give you some guidelines. And rather than give you like this table of steps to follow like they do in the book, I'm just going to tell you my strategy. And my strategy is very simple. I simply say, do I know this integral? And if the answer is yes, I do it. And if the answer is no, then there's pretty much only three options. Try a substitution and hope things work out. Try an integration by parts and hope things work out. Or sometimes you can even do an algebraic manipulation to get it into an easier form to deal with. Now all this is contingent on knowing what integrals you know. So in case you haven't built up strong intuition yet as to what integrals you know, I'll run through what we've learned so far. So the first technique we learned was about substitution. So we know when a simple substitution is going to work. So I call it a simple substitution if you can figure out what u is going to be just by looking at it, and you observe that du dx is present, which guarantees that that substitution is going to work. For example, in this integral, I can tell right away that u equals x cubed plus 4 is going to be a good substitution because du dx is 3x squared, and up to a constant du dx is showing up. There are a lot of types of integrals where integration by parts is guaranteed to work. For example, whenever you have a polynomial times e to a constant times x, or a polynomial times sine of a constant times x, or a polynomial times cosine of a constant times x, then integration by parts is guaranteed to work if you let u be the polynomial and dv be this other function. And also as a general rule, integration by parts works great if you can let u be natural log of x, or even something more complicated, u equal natural log of some more complicated function, and it's definitely something to try. And then we learned a lot of very specific integration techniques, trigonometric integrals of certain forms when you've got powers of sines and powers of cosines, or powers of tangents and powers of secants, or powers of cotangents and powers of cosecants. We learned techniques to deal with that. Then there's the type of integrals with trigonometric substitution is something to try. And that's basically whenever you have a quadratic radical, though in the simpler ones you'll have something like the square root of plus or minus x squared plus or minus a squared. They don't even necessarily need the square root for a trigonometric substitution to work out. And keep in mind that this works for whenever there's a quadratic expression, like, a squared or x squared plus, bx plus c that has that middle term, you can complete the square to get rid of the middle term and do a substitution to get things into this form. So trigonometric substitution is often the way to go there. And then the last specific type we learned was how to integrate rational functions. So whenever you have a polynomial over another polynomial, you can do the techniques about involving partial fraction decomposition. One final pointer here is a lot of times if you don't know what to do and there's a radical, doing a substitution where you let u be the radical often will work out, even if you can't see how at the beginning. So when none of these other techniques apply, that should be one of the first things you attempt. Now this isn't going to be super relevant to you for the problems I'll be asking, but it turns out there are certain integrals that are impossible to find in the sense that their integrals can't be expressed using the nice functions. We will learn techniques later in the course for expressing integrals where you can't express it with nice functions. So there are workarounds. But if you are out there trying to integrate things on your own, it's a good idea to have a sense for what types of integrals just don't exist in a nice way. And those are things, as you see here, listed at the end of the chapter, things like e to the x over x, or 1 over natural log of x, or any of these others. It turns out that it's impossible to find those integrals in a nice way. So if you ever, in some future class or in some real-world problem, encounter an integral like that, then you're going to have to know that you'll have to do it a completely different way where you don't actually try to find the exact integral. Now for the rest of this video, I thought I would just go through every other even problem and give you my initial impulse on what's the technique I would do to find these integrals. So this first one, for the integral of 3x plus 1 to the square root of 2, I can tell right away if you let u be 3x plus 1, then du dx will be 3, and substitution will definitely work. For 6, there's a couple of ways we can do this one. First off, it is technically a rational function over a rational function, so you could do, I mean, it's already kind of decomposed in the sense of partial fraction decomposition, but that might get it into an easier form if you go through that. But also, if you let u be 2x plus 1, you'll be able to solve that for x to get rid of this x and do it that way as well. For number 10, it's not of any known form of an integral. However, I have a good feeling, since that 1 over x is inside the cosine, if I let u be that 1 over x and then calculate du dx, I'm hoping something really nice will happen and it'll go into another form. In fact, thinking ahead, du dx will be 1 over x squared, so that'll cancel with one of the x squareds in the bottom, leaving just an x in the bottom, which is the same as 1 over x. So this will become the integral of u times cosine u, which could then be solved using integration by parts. So for number 14 here, for the integral of natural log of 1 plus x squared dx, honestly, when I first saw this, I wasn't quite sure what to do. You could try substitution where u equals 1 plus x squared. On the other hand, I have a feeling that integration by parts, since you have a natural log, if you let u be natural log of 1 plus x squared and dv just be dx, I think that'll work out really nicely. For 18, we've got the square root of t showing up in two places, so I would try letting u be the square root of t. In fact, now that I think ahead a little bit, actually letting u be the square root of t, du dx is 1 over 2 square root of t, so it'll just be a substitution straight away. For 22, I would let u be natural log of x. Du dx is showing up as 1 over x. It's already there, and you're just going to wind up with u over the square root of 1 plus u squared, which could then be solved. Honestly, that could just be solved doing another substitution. In fact, you could have done it all at once by letting u be 1 plus natural log of x squared. So for number 26, well, it's a rational function, so do partial fractions. For number 30, this is a bit tricky and doesn't really cover what I said, but since it's absolute value in a definite integral, you just split up the definite integral into regions where what's inside the absolute value is always positive or negative. And then where it's negative, you replace it with minus itself. Now they're starting to get interesting. For 34, I honestly don't know what would work right away. It's possible that you could do some kind of clever algebraic manipulation to get it better. But honestly, like, I would just have to try stuff. I mean, you've got cotangents. You could replace those with cosines over sines and try and rewrite it and hope for something good that way. And otherwise, I would play with it. But honestly, that one looks tough to me, and I don't have a great idea off the top of my head, but I would definitely just have to try stuff. For 38, it's a trigonometric integral, but it's mixing and matching sines and cotangents and secants. So honestly, I would first try to put everything in terms of sines and cosines without any better ideas. That's what I normally do, and hope I can figure something out from there, but it's not immediately clear to me what to do. For 42, we've got an arctangent. I kind of like to let u be arctangent x and do an integration by parts, because then du dx will be 1 over 1 plus x squared, and that is a lot simpler. So I would definitely try integration by parts on 42. For 46, whoa, this looks quite interesting, but it's got e to the x and, well, not a polynomial, a rational function. And then maybe a little bit of algebra could help. I'm not super sure what's going to work out well here, but my first impulse is to play around with integration by parts with different choices for u and dv. But again, until I got into it, I can't make any promises that one thing will work and another won't. 50, there's a couple ways to think about it. If you just let u be the radical, then you'll be able to get rid of the radical, you'll be able to get rid of the x's, and you're going to wind up with some kind of complicated rational function, but that could be done using partial fraction decomposition. 54, you want to do a little bit of algebra and multiply it out, and once you've multiplied it out, you can split it into several pieces. You're going to have an x squared, that's no problem, we know that integral. You're going to have a 2x sine x, that can be done with integration by parts, and you're going to have a sine squared x, and that can be done using the power reduction formula. For 58, this one again looks pretty hard. However, it doesn't hurt to be clever. I'm thinking integration by parts because we can let u be natural log of x, which is always great in integration by parts. But then dv would have to be x over the square root of x squared minus 1, but that can actually be done using a substitution. So that would be the first thing I try on 58. Wow, there's a lot of these. So that brings us to 62. Oh man, 62. 1 over 1 plus cosine squared theta. Honestly, I have a bad feeling that that's going to be difficult. Where to begin? Beats the heck out of me. I guess I would first try an integration by parts and then maybe a substitution and hope for the best there. 66. It looks pretty nasty. However, maybe if u doing a substitution where u is tangent x might work out okay. Or maybe even letting u be natural log of tangent x. I have a feeling letting u be natural log of tangent x would work out pretty nicely, or at least give you, that would be the first thing I'd try and do a substitution with u equal natural log of tangent x. 70 looks pretty difficult, I must say, but I have a feeling, I don't know. That just looks hard. Some kind of algebraic manipulation. Maybe this could be expressed as a perfect square, or maybe this could be factored somehow. I suspect that there's a way to factor the bottom, and that would give a clue to let u be something in like a substitution or integration by parts, but I'm really not super sure at first glance. 74, honestly, this can be split up into two fractions, and then all the stuff can be expressed in terms of e's. Like 4 to the x is e to the x times the natural log of 4, and once you've done that and simplified, it'll become not too bad. 78, I would suspect that you could do some kind of clever algebraic manipulation. Multiply the top and bottom by 1 plus sine x, and the bottom is going to become 1 minus sine squared x, which is cosine squared x, and hope to do some kind of technique using trigonometric integrals. And finally, for 82, yeah, I am really not super sure what to do on 82. There's a lot you can do. Play around with Pythagorean identities, maybe letting u be something like sine squared, cosine squared, maybe trying to find a function whose derivative is sine x, cosine x, like cosine squared or sine squared. That would be my first thought, but until I got into it, I couldn't tell you. So those are my ideas. Note that a lot of these I don't know what's going to work out right away, but I know I have to try something. Other ones I've built up intuition over the years, and I have a decent sense about what's going to work. So you will have to develop that intuition on your own, and you just got to get there by trying it, see what works. Don't give up. Keep pecking at it until finally you find a way to crack these problems. But keep in mind they are all super fun, so I hope you have fun trying these, and I'll see you all later.